Okay, so this is a little demo to show how I do my robotics development in Squeak. Um, so first off, I'm running Squeak. I have my classes all in these 5 categories right now. They'll all start with RAWs. So I have a Monticello browser um, with this package, RAWs, and a file-based repository and a local directory here. That's in Dropbox, but it doesn't sync to the robot through Dropbox because there's no Dropbox client for Raspberry Pi. So the way I sync it is I run rsync using this command right here, and that's running in this terminal right here, and I just start it and leave it running. So when I make a change to this, I'm going to just put in here, make it just a really simple change here. Change the log statement starting run for demo. So this comes up, click on it, save, demo test, and then I'll accept that, and that produces ROS.50, and you saw this thing just copied it to the Raspberry Pi. And now here on the Raspberry Pi, I have a folder called that, and you can see they're all here, including ROS.50, which is the latest one. I also have a file in here called ROS.sh, and that basically just is a shell script that runs this command. Starts at the Squeak VM in headless mode. Here's my image, which is just the standard Squeak 6 base image, and then execute this little file which contains some Smalltalk code. This file basically is this piece of code here, so it gets the MC directory repository on that particular folder on the Raspberry Pi, the one we're rsyncing to. Grab all the file names in the first one, which is always the latest one. The version named that one load, and then robot raws run, and then basically snapshot false and quit true. So it'll exit Squeak when it's done. So robot raws basically just builds an instance of this robot. So it builds a new robot, it adds head and tail and legs and sets some stuff and walks through the legs and sets the leg joint lengths. All this stuff is for, a lot of this stuff's for inverse kinematics and the gait, various parts, the sensors, and sets up back references to the robot and then returns it. And run is very simple. It's the log statement we just did. When you say self log, by the way, it just logs to a local file, and it's called raws.log, and it just logs some stuff, including a date timestamp and who's asking and whatever. So getting back to run, so connect to the interface, which is the serial interface for the servos and the sensors. Log, we transition to standing pose, which is a fixed pose where all the servos know where they're supposed to be. Create a random walk navigator for the robot. Set the cycle time at 20 milliseconds, which gives us 50 frames a second. And then as long as the navigator's not done, basically sit in a tight loop, tell the robot to update, tell the navigator to update, and if we've used up less than 20 milliseconds, then delay for the rest of the time. And just keep doing that until it's done. When it's done, we log done that navigation and disconnect from the serial port. And of course, all protected by an exception handler that dumps a walk back when it, which is what this does, if it gets an error. So it's pretty straightforward. Right now I'm doing I've got 2 terminals open on my Raspberry Pi. This one runs tail-f raws.log, which is an empty file right now, and this one I just say /raws.sh and start it running. It takes 30 seconds or whatever to start up the image and load up that code, and You'll see it start to come out in the log here when it's running. There it goes, it's transitioning. It's got the stuff from these guys. I start the robot, it's walking. I stop it and it's done. And you can see this is dropped back out of Smalltalk to our command prompt. And basically I'm dumping info from the sensor manager. I've got 5 rangefinder sensors, IMU, yaw, and flow X and Y are part of the down-facing optical flow sensor. So yeah, so that's it. Basically we do that, push the button, transition from, well, at the very beginning we push the button and it transitions from a few different states in the state machine and finally starts walking. And then at the end, every now and again I punch out the bus voltage and things like that because I'm watching for those values. And then we exit walking, enter shutdown, and then we're done navigation. And that's it.